Hi, and welcome to today's event, Unlocking BigQuery, Achieving Speed and Scale with Data Observability and FinOps. My name is Clinton Ford. I'm Director of Product Marketing at Unravel, and today we are going to take a look at how data observability and FinOps for high-volume users of BigQuery is enabling amazing new capabilities. We'll discuss how you can maximize the business value from your data assets at today's speed and scale through performance and efficiency enabled by AI that is purpose-built for your data cloud. So here's a look at our agenda. We'll start off with some of the common challenges facing businesses today and the market drivers out there. We'll talk a little bit about the pricing changes with Google Cloud BigQuery additions and an overview of Unravel for BigQuery. And then we'll have a demo by Eric Chu, our VP of Product at Unravel Data. And following that, if we have time, we'll take some questions at the end. So there are four things that are creating friction and resistance for organizations as the demands of AI are getting higher and keeping data pipelines running is getting more complicated. The first is data spend forecasting is like a roller coaster. It's difficult to reliably predict, disrupting financial operations. The second is the pace of adding new data workloads is limited by budget and skilled resources available. It's like chaining an anchor to your race car. Budget and staff resource constraints slow cloud data adoption. And new AI models are exponentially increasing scale and data volume and data pipeline complexity, thereby adding even more pressure to budget limitation issues. And the mean time to repair critical data applications is slow due to the tech stack complexity and toilsome metadata correlation that tie up all of your critical skilled data resources that are needed for faster innovation. So cloud data costs are exploding, and within the overall cloud bill, data management services are the fastest growing category of cloud service spending, representing about 39% of the total cloud bill. About 81% of 753 global cloud decision makers and users surveyed reported managing cloud spend is a top challenge. Budget and talent constraints are creating real risks to data and AI projects. Production environments are statically over-provisioned and therefore overly costly. On-premises 30% utilization is common, but it's all capital expenditures or CapEx. And as long as it's within budget, no one has traditionally really cared about the waste. However, in the cloud, you pay for that excess resource monthly. So it's forcing you to confront the ongoing costs of this waste. And the cloud skills gap has reached a crisis level in many organizations. Data is foundational to AI, and yet unstructured data remains largely untapped. Organizations today view the cloud as a highly strategic platform for transformation that's requiring cloud providers to offer more sophisticated capabilities as the competition for services heats up. So for example, generative AI is supported by large language models, which require powerful and highly scalable computing capabilities to process all of this data in real time. And data pipelines are becoming increasingly complex, slowing innovation. For example, among the various reasons that data projects in manufacturing stall is the issue that legacy technology, on-premises and cloud data warehouses, are too complex and costly for growing volumes of data from connected products and operations. So Google recently introduced a pretty massive change from the pricing models that have existed, and that's affecting both compute and storage, as well as services. You'll also see a component of services. So the two biggest components of the new BigQuery editions pricing are compute or analysis pricing. This is the cost to process queries, including SQL queries, user-defined functions, scripts, and certain data manipulation language or DML, and data definition language or DDL statements. And then storage pricing is the cost to store data that you load into BigQuery. So storage can be either logical, which is the default, or physical. And if customers convert storage from logical to physical, they can't go back to logical storage. So in order to overcome the 4 common business challenges, go faster, and gain a competitive advantage, BigQuery users really need 3 things. First, visibility for cost allocation, chargeback, and accurately predict the spending at the job and user level. They need AI-powered insights to run more data workloads within their existing environments, and automation to launch new data applications faster and reliably achieve their SLAs. So how does Unravel enable organizations with visibility, insights, and automation? Well, first, deep granular visibility. So with Unravel, you can get down to the user, project, and job level. We have an AI-powered insights engine. So with that visibility, now you can do a lot of interesting things. So now you can start to see recommendations and insights based on what's happening. So you know not only what's going wrong, but also how to address it. And finally, third, automation for immediate responses. So Unravel provides an automation engine that you can look to for events and notifications and tailor this to your own environment. So Unravel is designed for your specific data platform and ecosystem. Unravel 4.8.1 enables Google Cloud BigQuery customers to see and better manage their cloud data costs by understanding specific cost drivers, allocation insights, and performance and cost optimization of SQL queries. So this launch is aligned with the recent BigQuery pricing model change that replaced the flat rate and flex rate pricing with 3 new pricing tiers, and will help BigQuery customers select the right new pricing plan based on their usage and maximize the workloads for greater return on their cloud data investments. Unravel's cost optimization intelligence for BigQuery delivers insights based on Unravel's deep observability of the job, user, and code level to supply cost optimization recommendations for slots and SQL queries, including slot provisioning, query duration, auto-scaling efficiencies, and more. With Unravel, BigQuery users can speed cloud transformation initiatives by having real-time cost visibility, predictive spend forecasting, and performance insights for existing workloads prior to moving them to the cloud. At the core of Unravel Data's platform is its AI-powered recommendation engine, purpose-built for specific data platforms, which understands all the intricacies and complexities of each modern data platform and the supporting infrastructure to optimize efficiency. This insights engine ingests and interprets the continuous millions of ongoing data streams to provide real-time insights into application and system performance, and recommendations to optimize costs and performance for operational and financial efficiencies. Unravel includes out-of-the-box and customer alerts and dashboards. So BigQuery customers can also use Unravel to customize dashboards and alerts with easy-to-use widgets that offer insights on spend, performance, and unit economics. Unravel 4.8.1 includes additional features such as showback and chargeback reports, SQL insights, and anti-patterns. You can compare 2 jobs side by side, enabling you to point out any metrics that are different between 2 runs, even if the queries are different. With Unravel, you can achieve your goals. You can run 50% more workloads in the same environment, launch new data applications 3 times faster. Unravel enables data teams and finance teams to collaborate, and Unravel gives data engineers a streamlined CI/CD process to check their code before deploying it to production. You can accurately predict your spending to within plus or minus 10% of actuals, and reliably hit 99% plus SLAs. Unravel enables you to run 50% more workloads at the same budget. So it has purpose-built AI that identifies inefficient jobs at the code data layout, partitioning, and infrastructure levels. It has fine-grained visibility to the job and user levels to prioritize the biggest opportunities to improve efficiency. AI insights pinpoint where to improve code, SQL, joins, data layout, partitioning, and infrastructure. And automated alerts and actions prevent accidental overspending. So customers are experiencing incredible return on investment with Unravel. For example, a leading global logistics company saved $20 for each dollar invested. Unravel enables you to create new apps 3 times faster. AI Insights recommend detailed actions to improve code, SQL, data layout and partitioning, and infrastructure before deploying to production to speed cycle times, so engineers spend less time troubleshooting and optimizing performance. Purpose-built AI provides an expert in a box to enable all skill levels to be proficient, which increases the overall capacity of development. By leveraging Unravel, organizations have been able to actually expand that possibility and put an analytical tool into the hands of their business users to evaluate their code before it goes into a release. So for example, DBS Bank, they've exponentially grown their data platform in the past 5 years by almost 100%, by almost 100 times. And they had no viable mechanism to catch code deficiencies and how to improve. But with Unravel, they enabled tens of thousands of ML models, and developers use Unravel to evaluate code before it goes into production. So Unravel helps you accurately forecast spending with granular cost allocation at the job, user, and project levels to enable real-time visibility of ongoing usage. Purpose-built AI understands usage patterns over time mapped to your specific cloud infrastructure pricing. Fine-grained budgeting provides actionable awareness of spend levels before it's too late, and automated spend controls prevent accidental overages and runaway jobs and non-compliant workloads. So FinOps is a major area for Wells Fargo because a lot of the other banks and financial institutions have already made their way into the cloud. But what they're noticing is that they're struggling with costs on the cloud. Everybody thinks about the cloud as being cheaper, but it actually turns out that organizations end up spending a lot more money there because of the value that is derived from it. So the business that is going to move more to the cloud needs to ensure that they derive a lot of value from their investments. And IT leaders now have to understand who is responsible for the cost and which department or group is realizing the value. So Wells Fargo is able to bring these capabilities together with Unravel to really see all the cost information together, not only overall costs by cloud service provider like AWS, Azure, and Google Cloud, but also by project, by line of business, by application, by product, and by individual user. So now they can look at the cost and gather that cost data down to the finest level of detail and then roll up each of those costs. And FinOps isn't an individual effort, it's a team effort that requires everyone to have visibility into the information. Unravel helps you achieve 99% plus SLAs for your data workloads with purpose-built AI that provides detailed instructions to optimize code, SQL, joins, and infrastructure allocations based on your SLA requirements. Automated AI insights provide ongoing alerts on problem areas before they occur, and granular correlation of metadata down to the job level with detailed AI insights enables immediate real-time troubleshooting for faster mean time to repair. So for example, Deutsche Bank accelerated resolution times for data pipeline issues by 98%. They were challenged with maintaining SLAs, and they had a fragmented tool set with different monitoring interfaces and over 100 different log stores for debugging. They scaled workloads 5x using Unravel. And using AI insights, they accelerated the mean time to repair and reduced their ticket volumes by 70%. With Unravel, you can achieve your goals, run 50% more data workloads in the same environment, launch new data applications 3 times faster, accurately predicts spending to within plus or minus 10%, and reliably hit 99% plus SLAs. Unravel's purpose-built AI is built from the ground up for your cloud data platform and ecosystem. Unique AI models are built specifically for each data platform, for Databricks, for BigQuery, for Snowflake, EMR, Cloudera. The AI is trained to understand data ops and FinOps specific use cases and best practices. And the AI learning extends to supporting infrastructure surrounding these tech stacks and data pipelines. Unravel is the most proven data observability and FinOps platform. Unravel is a member of the FinOps Foundation and named Best Data Tool and Platform of 2023 as part of the annual SIIA Cody Awards, named to the Big Data 100 list for the 5th consecutive year, and amongst the inaugural group of coolest data observability companies of 2023, and named by Gartner as a sample vendor for both data observability and augmented FinOps. All right, now let's see Unravel for BigQuery in action. So Eric, over to you.
All right, thank you, Clinton. Hello, everyone. It's great to be here today. So I'm going to show you a demo of our Unravel BigQuery offering in 4810. As Clinton has explained, in FinOps, we have the inform, optimize, and operate phases. So the scenarios that I'm going to demo today also fall into those three categories. First one, I'm going to show you how the FinOps practitioner will use Unravel to understand how much they are paying for BigQuery in their organizations. Then I'm going to show how they, and along with the engineering and operations side, identify the most impactful recommendations to optimize the overall cost and performance. And when we drill down, the engineering leads and the product owners will then identify the most impactful recommendations for their own projects that they have to optimize the cost and performance. They will then in turn work with the data engineers on their teams to debug a job, comparing job performance, and identify expensive and inefficient and failed jobs overall. And lastly, I'm going to finish with a demo on how do we set up alerts to monitor live BigQueries for the operate phase. So now I'm switching to a playground of the Unravel BigQuery support. This is data on Unravel itself. First, after you log in, you are going to go to the cost page and you see this cost 360. So this first scenario, to understand how much you're paying, starts off with this dashboard. On the top right, you can see there's a time control where you can select any time range that you like. And then what you first see is the total cost over this time period. So for example, now we're looking at last 30 days, and then we'll see that the total cost used by Unravel for BigQuery is about $23K. And then on the right, you see the trend, daily trend of this cost breakdown for the same time period. So you can see how this trend, the cost varies day by day over the last 30 days. So this starts off with the overcost, and then we'll take a look at how the cost is broken down in various aspects. As Clinton explained, in BigQuery pricing, there are three components of pricing, two of them being the dominant ones. The first one is the compute pricing, the second category is the storage pricing, and the third one is the various services that you have to pay. So that in Unravel is shown up as the others category. And the very first breakdown that you see is a breakdown over compute, storage, and other. And then you soon see a pattern where usually when we talk about chargeback, we'll show you on the left side the chargeback over the period that you have selected on the top right here. And then on the right side, you'll see the daily breakdown of the same amount so that you could see the trend. So drilling down from the top level, you see that we also break down by the cost at the compute side, as well as the storage side. Here on the cost side, you see that on the in BigQuery pricing, the main cost plans are the on-demand and the capacity-based. And then the capacity-based, Google has also changed the pricing plan since July 5th. Specifically, it has deprecated support for flat rate and flex slot and replaced them with a tiered model, which has 3 editions: standard, enterprise, and enterprise plus editions. For users who have been using the flat rate, that they will continue to see flat rate until that plan has expired, or the users have changed the flat rate plan. So for in Unravel, you see all those show up in the Cost 360 dashboard. We get the source from the billing itself, so these are accurate, and you see whatever you pay will show up here. So here you can see we have a breakdown between capacity and on-demand, and then for the capacity part, we have shown you all the old and the new pricing plans, from flat rate to the various additions. On the right-hand side, you can see this breakdown over both on-demand and the capacity base. And in addition, within the capacity-based planning, we show you the breakdown between the flat rate, standard, enterprise, and enterprise plus additions. And you can see this daily trend to see exactly how your plans have changed over time. And all this would be the same when you have selected a different time window on the top. Going down further, you will see that the storage breakdown. So the storage breakdown, the thing you need to know is that in BigQuery storage, there are 2 concepts. One is whether the storage is long-term or short-term. Long-term is something where is that you don't have any changes on the table for more than for the last 90 days. Whereas active means that any table or partition of that table has been modified in the last 90 days. So the pricing for the long-term and short-term vary a lot. It's the long-term storage is actually about 50% of the active storage. So keeping track of how much you have long-term and short-term is very important. And we do have recommendations to tell you so that you can encourage more long-term storage. So here you can see the breakdown between the long-term and short-term, and then physical and logical. What physical means is that it is for where data is compressed, and the price is based on compressed bytes. The interesting thing about physical storage is that the unit price for the physical storage is actually more than the unit price for the logical storage. But because the price is based on the compressed bytes, it often is less than the logical storage. The other thing to know about physical storage, which is actually in preview, it's not GA yet from BigQuery, is that once you have converted from logical storage to physical storage, you cannot change it back to logical. So you need to do some testing to see whether for your specific data set, you are indeed getting less charge by switching to physical before you actually do that operation. But over here, the goal of this dashboard is to show you visibility into how much you're paying and what you're paying for. So for the storage, we are showing you the breakdown between the 4 combinations of active versus long-term and logical versus physical. Here with the Unravel data set, because we haven't converted any logical storage to physical, we are not showing that in the breakdown. But as soon as we've done that, then you'll see it in the charts. The last part is the other cost breakdown, which comprises services that incur cost. These are often of minor component. They are a minor component of the total cost, but still, we wanted to show you just in case there's some surprising increase in the cost associated with these services. Then you'll be able to see suddenly that you can track them. Again, in the Unravel data set, we are not using any of these services, and that's why you don't see data here. Now, the next thing that people are interested in when they're looking at the cost is how much they are paying per project. Project is a basic notion in BigQuery where different teams may have different projects as a logical separation of their work. Here you're seeing, again, sourcing from the billing data, we're able to show you the accurate cost, chargeback per project. And on here, what you see is the total cost over that last 30 days by projects, as well as the daily cost and the number of projects as a trend. Here, the green line is serving as the average cost per project. And the purpose of that is to give you some idea of the unit cost. It's very important to remember that in FinOps, we are not trying to minimize the total amount of cost, but we wanted to maximize cost efficiency. Because often when your business grows, you do need to spend more on the cloud. You have more workload that are supposed to happen. So it's not if your business grows, then you will actually expect to see the total cost grows. But it's important to know that these cost increases are justified by spending efficiently. So there are various ways to measure the cost efficiency, and that commonly known as the unit cost. There are different unit costs. One of them is how much the revenue is compared to how much you're spending on the cloud. In Unravel, we are by default storing how much you're using BigQuery and how much you're getting charged for. So the revenue data is not by default available within Unravel, but you can. We also support API where that allows you to extract the any information from the Unravel dataset into your favorite BI tools like Power BI, so that you could combine the cost data with your revenue. Out of the box from Unravel point of view, we do also want to provide some measures of unit cost. So even though we don't have revenue data, what we can do is to show you the average cost per project, per user, and per job, so that you could get a sense that when the total cost is increasing, whether the average cost is staying the same. So that's the trend that you want to look for. Below these charts, you see that we are also showing the on-demand cost chargeback and the capacity cost chargeback by projects. Again, this is from the billing data, so this is accurate. Storage is the other one that we're doing the chargeback by project. And because we don't have physical storage, we don't have the cost here, but you can see the logical and the breakdown between the logical, the long-term and the active by the different projects. Getting to the next level of chargeback is interesting because now we are looking into the chargeback by user and jobs and the trending by jobs. And this data is actually not available in BigQuery. So BigQuery has some billing dashboard to show you how much you're paying, but those billing dashboards are mainly at the high level of how much you're paying for GCP. You can select set up your filters to look at how much you're paying for BigQuery, and you can see the project base, and you can see the project based, how much you're paying per project. But it's not easy to find that, and that's the deepest level you can go. But often what customers need are the query level, the user level, a breakdown of costs. So that's something Google BigQuery doesn't provide, but Unravel does. So Unravel does this by monitoring the projects that you have hooked up with Unravel, and then any project that you have hooked up with Unravel to monitor, we would see all the jobs that are happening. And then based on the pricing plan and the resources and the KPIs, we could compute an estimated cost for each user and for each job. Actually, the user part is coming from aggregating by the jobs that we monitor and the cost associated with each job that we compute. So this level of detail is only available within Unravel. And that means it is important for you to hook up as many projects for Unravel to monitor as possible. The first thing we show is how many total projects one has. So this number is coming from the billing source that we see. And then the blue dots that you see here is the number of projects that are monitored by Unravel. So the accuracy of your data about the job level and user level costs will depend on how many projects you have set up Unravel to monitor. Now, coming down, now you see all this data that Unravel is monitoring through the projects, and you can see the chargeback for user, and as well as the trends for the number of users and the unit price, the average cost per user. Here, because we are computing the cost at the app level and then aggregating at the user level, it does make a difference depending on whether we're talking about on-demand or capacity-based. On-demand is something that you pay as you go. So we do have a very straightforward cost notion associated with it. On the other hand, capacity-based is something you prepay. So you have pay for certain slots usage, and then you have capped it. That could be specified via different reservations. So in that model, even if you don't, regardless of how many queries you run, you have already paid for that amount of resources. So the way that we use to capture how much each job or each user is paying is incurring as a cost. Instead of the money, we are using slot MS, which is also a metric used by BigQuery to actually compute for the real cost, except that in the capacity-based model, this is something that you have already paid. So here, what we want to do is to mainly track chargeback, and then how we optimize the cost will come from our reservation insights or other insights that would right size the reservation that you should use, given the workload that you have demonstrated. So here, just to recap, we're showing user and job level chargeback and trends. And then over here, you also see that we have daily trends for job count for both the on-demand and the capacity. And that for capacity, because it is something that the job and user level estimate data are something that we compute. For the capacity-based plans, we won't be able to give you values in terms of dollars, but instead we'll give you values in terms of slot MS. Okay, so this covers the scenario of FinOps people trying to understand how much they're paying. Next, I'm going to go over the scenario where for the FinOps practitioner, the product leads and the dev leads, how do they spot the most impactful insights so that they can right away know what to optimize? All the queries that Unravel monitors automatically get analyzed for any opportunities to optimize the cost and the performance. And if you go to the jobs detail page, the job list page, you see that we have an extensive list of insights related to jobs and schedules and reservations, etc. But often, one other challenge is there's so many insights. How do I know which one I should optimize? One way you could do is coming over here, you could do different filters to select the group of jobs, the subset of jobs that are of interest. Maybe selecting only the long running jobs, maybe selecting jobs that are have some brackets of build bytes or slot time, or by the insights that we show. Here we have designed this dashboard to show you overall across all the projects that we have monitored, what are the top K insights in each categories of insights that we support. So this is a good segue to look into the insights that we support. There are 4 categories at the high level. One is the reservation, which is about how do we right size the reservation that you should do for the capacity-based pricing? So each reservation is a pool of slots, and slots are the basic BigQuery capacity units. It basically is virtual CPUs used by queries. So given a reservation, you can set the baseline slots, which are the slots that are always allocated, as well as auto-scaled slots, which are added or removed dynamically based on the demands of your workload. So one reservation can be used by multiple projects, and each project can also specify different reservations to be used for the different job types. So in BigQuery, there are 4 job types: query, which are the SQL queries, and then you also have the load, copy, and extract, which are just statements that are typically done through the GUI to load data, copy data, and extract data. For the most part, people are concerned about the query, but we show visibility into all 4 types. And as an admin, you can also specify that different types of jobs use different reservations, so they don't get the resource contention. Now, knowing that, we wanted to, the key to optimize the cost is to right size the min and the max slot for the baseline and the max slots for your workload. So here, what we have done is we automatically, by tracking all the jobs and applying our AI algorithm, we automatically come up with suggestions on whether you should do that. So here you could see this one is an example of a reservation insight where we would tell you the different approaches on how to optimize that. So so these approaches vary by how aggressive you want to save costs. In general, if you wanted to save more costs, like optimize for cost, then you would have a lower cap for your max. So that means when there are more queries, then there would be more waiting for the finite resources that you have allocated for that. And the pro is that you would have capped the cost, and so you would ultimately save it. The cons is that the performance of those queries may suffer because they actually don't have enough resources and they will have to wait a little bit. So that is a trade-off that one has to make. How much are you willing to sacrifice for your cost, for your performance, compared to how much cost you save? So in the optimize for cost approach, what we do is that we'll guarantee that there are no performance impact for 90% of time based on the workload that we have observed. And then we'll give you an estimated savings. Now, there is another approach, which is optimized for performance, which means you really cannot afford any of the queries in your in the past data to slow down. So we would come up with a guarantee that if you switch to the recommendation setting for this approach, the performance impact, there would be no performance impact for 99% of time. And then you would, with certain estimated savings, usually this savings would be less. There could be some cases where based on your observed workload, actually it doesn't matter. Like even if we guarantee a higher percentage of no performance impact, end up you save the same thing. And that is normal. That could happen. It's based on your workload. But typically, you can expect that when you optimize for cost, you have a higher savings and a lower performance impact guarantee, and vice versa for optimize for performance. There's also a balanced approach where actually it just means that it is in terms of the performance impact is in the middle between the optimize for cost and optimize for performance. And then the estimated savings typically is also expected to be somewhere in between the two extremes. So based on these 3 choices, one can choose what is the best suitable for their use case. And then you could go to the BigQuery, the Google GCP GUI to adjust your settings for your reservations. The next category of the insights is about job insights. So these are insights at the job level. And here we show you the top 10 most impactful job insights by the query templates. So query templates here are referring to different runs of the same query. So especially you can have recurring queries, recurring jobs in BigQuery. And there's a schedule even that you can specify, like you run a certain query every 2 minutes, every 2 hours, etc. So over time, you would have a lot of the same runs over those queries. And what we do here is we look at all these recurring queries and others, and then we calculate some impact score on what insight, like for the insights that we recommend you to take. If you do them, how will that impact the cost of the job so over here, you can see the top here, the job statement, how many insights have we caught, what are these insights, and the impact score. The impact scores are used just to rank the impact of these jobs and the insights for these jobs. So by themselves, they don't really mean anything. So it's just for ranking. And then based on this page, you can click on it, and then you can go to the actual query to see all the different insights. And to understand how many insights, the best way, what insights do we support? The best way is to come over to the jobs page and then go to the inefficient tab, where we would show you all the jobs that have all the jobs within the time range, which is 30 days. In this case, is the range that it has carried over from the other page. And then it will show you what insights we have there. But coming back to this insights page, the second category of insights is job level insights. And we show you what are the top K most impactful jobs, the query signatures with the insights that you wanted to apply. Next, we have scheduled query insights, which is talking about earlier when I mentioned that you have some of your queries are recurring. And in BigQuery, that means you have a schedule associated with it. So this is something that is a common source of paying too much for customers because they run too often. Now, Unravel doesn't know whether or not you really need to run them as frequently as you have chosen. So what we have done is we show you all the recurring queries that have schedules that are quite frequent, and then we would show you that the estimated amount that you can save by reducing the frequency. So the main point here is to get you to review your schedules and make sure that there are no blind spots. So you can make the decision with your best judgment, and then schedule the queries as frequently as needed, not overscheduling them. The last category of the insights is about is at the project level, where users have the option to specify a quota for the project. So there are two types of quotas. One is the project level custom quota that limits the aggregate usage of all users in that project. The second quota is a user level quota that applies to any user or any service account within a project. So anytime when you have exceeded the quota, the new job that comes in will be canceled, and so you don't get a charge. In a way, it's Google GCP's way of letting you specify a cap per project for the two different use cases, one for the whole quota for that project, and then the other one is each user level. So all these quotas are reset at midnight Pacific time. And you can click on this link to learn more from the Google's own documentation. What Unravel does is we will tell you what control you have set for the different projects, and then we would also tell you, give you recommendation for what project level, user level quota to set based on a 99 percentile of the daily usage over the last 30 days. there are different algorithms, different heuristics to do such thing, and there's no one right way. It all depends on your use case. So some people may actually have a pretty normal level, pretty level usage over time. So maybe they just want 100% percentile, like all the queries observed in the past 30 days. If they repeat again, they want to make sure they are all running fine. So in that case, you wanted to set it higher. But then, oh, actually, excuse me. So this is 1.5 times the 99th percentile, not the 99th percentile itself. So we actually set it pretty conservatively, just so that all your queries, if they're running fine, then none of them should get canceled. But setting a cap has the benefit of preventing outrageous outlier. So we have a customer who actually, before using Unravel, they have one person running query overnight, and suddenly that one query costed them $70,000. They had to go to reach out to Google and talk about accidentally triggering that query, and then Google eventually forgave the cost of that query, but it's quite a scare, as you can imagine. So the one good way to do that is to set up a quota, so that anything that, like, before they get too close to that outrageous category, they would get killed and canceled and stopped. Of course, if you set it too aggressively, then a lot of those queries that normally you would want them to finish may get canceled. So that's why it's important to understand your usage in terms of percentile. Now, here we have sometimes these categories of insights may have way more than 10 insights, but we have capped it to at most 10 for the first round, so that people know what to focus. So this page is really good for people who want to just quickly find out what are the most impactful insights to take actions, and come here to identify them. The other option that I have alluded to earlier is that when you come over to the jobs page, you could actually you could browse and select the different types of insights. You could select based on the user, based on the projects. So this page is more for discovering what are the jobs that are of interest to you or your team, and then drill down into what you can do. So the way to for the people, for the dev team, the engineers, to really look at the insights is to come to this page and browse. And then here you can also check out what insights we have. Some of these are more informed, like telling you that you have insights that you have queries where it's running significantly longer than the average prior execution. And so you wanted to take a look because something may have changed. And then sometimes it's about anti-patterns, like a bad practice that people should avoid. Like the famous example is if you select too many columns that you don't need, or sometimes people just do select star to try to get a sense of what data is in there without knowing that it would do a total table scan. So all those are pitfalls for causing expensive queries. One common pattern is not using the partition key. And partition key, we also have insights. And you can see the different insights here where we have expensive operations to tell you which operation within the BigQuery job that is most expensive that you should optimize. Move jobs to a different queue. So this one to a different project. So this one is about to tell you that, hey, maybe instead of using an enterprise plan, instead of using additions plan, you can move to a different additions to save money. So so this is also another good example of job level insights where we can identify all these jobs that you should move to a different pricing plan to immediately save money. So the one way to quickly find out what are all those insights is by going to the jobs page and then just selecting the only for that insights, and you can find out all those. And this is also an example of achieving an immediate cost saving, as opposed to some of the other jobs that insights which are more on the informed cases. Now, if we look further down, we also have too many columns. So that is to tell you not to select only the columns that you should use. Reduce scheduled job frequency. This is the same as what I showed before in the insights page, where we want to show you there are recurring jobs that are being scheduled quite frequently, and we want to ask you to review whether those schedules are justified, and if so, if not, you should reduce the frequency to save cost. Select star, we know too many rows as a result, so all those pertain to scanning too much data, and you should limit them. Slot contention is an indicator of maybe performance issue. Maybe you actually want to increase your max or move some of the queries to another pricing plan, to another reservation, to free up the slot contention and improve the performance. Long wait time, again, this is pertains to performance. And then change in input size is more of an anomaly category. So telling you that some of these insights, some of these jobs, they have been running several runs in the past, and then suddenly you are seeing a run that has greatly differed in the input size, and you just wanted to check to make sure that they are expected. And then partitions not prudent is the one that is referring to when you are not specifying your partition keys, you're scanning the whole table as opposed to just the partitions you need to scan. And so that is one major cause for often running queries that are too expensive. And then the partition is also one way to keep your storage long-term as much as possible. Because once you have partitioned your table, usually partitions are based on the insertion date. So if you partition by insertion date, then all those older partitions, when you just read from them, they are still considered, you won't change them to active storage. They will become long-term after 90 days. And then when you create new partitions, those are the ones that will become active, but then you have limit your rights to only to the latest partitions. Comparing that to not using partition keys, if you just have a table unpartitioned, then anytime you write something to a table, you cause that whole table to be counted as active storage. So that would keep your storage price very high. So partition and clustering is definitely one thing to keep in mind, and we provide insights to tell you whether you should partition or not. So let me do a time check on the scenarios that I have described and covered. So debugging a job. Okay, so I have debugging a job and comparing jobs, and then live monitoring with alerts. Okay, so now for debugging, we also come back to this jobs page. Normally, if you go to a jobs page, you could see the insights. You could see you could also see the query, and this is one of the biggest advantage of using Unravel compared to BigQuery, because BigQuery in the GCP BigQuery console. The reason is that when you go to the GCP console, when you go to the BigQuery part, all you see is the query text and some high-level metadata. You actually don't get insights on why something failed or why something is inefficient, and you also don't see other same statement jobs. So here, it's very easy for you to just come over to the query detail page, click on this tab, and see all the different runs that are exactly the same as your query. So you could easily compare different runs and do a side-by-side comparison, such as what I do, and then see what is different. So here, when you have we have a side-by-side job comparison feature that allow you to look at 2 runs of the queries and then compare what is the difference, and then you also here by default we show you only the fields that are different, but you can always turn it off and see all the views that we're comparing. You can also look at the exact query text if it's too long to be shown in just a snippet, or you could switch to different sections or switch to different jobs easily. And this comparison doesn't require you to put two exact same queries. You can just put any different queries. So if I just come back over here and then I select this one and I select another one, I think these are different. Then I do the compare jobs. Then you see that, hey, these two are different queries and they're very different price, etc. Right? But and sometimes you do need to compare different runs that have different text, because sometimes you may they may actually represent the same use case, except one you have you specify the partition key versus another one where you don't. And so those two queries are actually doing the same job, but they have different text. So it's not just the same text query that you care about, and that's why you want to sometimes you want to compare any different jobs. The last thing I wanted to show is that alerting, where in this iteration, we are using OpenSearch alerts that allows you to create alerts that are that allow you to capture the jobs based on monitor live jobs that are running for too long, based on the duration or based on a slot MS. So the cost part, because it is not available live, is something we compute. So we don't have the monitor by cost, but we have it for the duration and we have it for the slot MS, especially useful for the capacity planning. So the nice thing about the OpenSearch is that this is highly flexible. You could actually configure this yourself and use this to monitor anything that Unravel data model captures. So the same goes for dashboard as well. Any dashboard that you don't see, Unravel actually exposes the data model and the data that we capture, so you can easily create the new dashboards, new reports, or new alerts for your custom use cases. So with that, I think I have gone to my time slot limit, and I think I'm going to stop, and I'm going to give it back to Clinton and go to the next step. Thank you very much.
All right, thank you, Eric. That was an amazing demo. Really appreciate it. And we'd like to thank our audience as well for all the questions that have been coming in. So Eric, here's a question that came in during your presentation of the demo. If I use ChatGPT to write a query, will Unravel help me detect anti-patterns in my SQL query?
Actually, that's a great question. So the question is, if somebody uses ChatGPT to generate a query, would Unravel be able to tell that it's inefficient? And the short answer is yes. Unravel doesn't really care who writes the query. We simply record it. So I think in practice, what people would do is like they use ChatGPT to ask some natural language question and then get back from ChatGPT a SQL query, and then they just run that SQL query instead. And so that SQL query will still be under that user's name, whoever submits that query. But we're simply, we don't even think about whether that person really writes that queries. We just analyze it automatically, and we would be able to tell you all the inefficiencies that we detect.
Well, thank you so much, Eric. That's awesome feedback, and appreciate the great demo and answering questions on here today. And for any attendees, if we didn't get to your question, please feel free to reach out to us. We'd love to continue the conversation. Again, take a look at our unravel.com/events page to register for our next live event. And we look forward to seeing you soon. Thank you so much.
Thank you. Bye-bye.
Bye-bye.